How's it going, y'all? It's Ryan. All right, I'm gonna put on some more entertaining music to keep the beat up. Actually, let's do a different tune. All right, this one's interesting. And actually, let's go with a different one. Okay. All right, so today we are going to be covering the introduction to APIs. So if y'all don't know me, I'm Ryan from Major League. I'm a coach here. I am also a lettuce enjoyer. So if you like using emojis, please spam the lettuce one whenever you get the chance to. Nice to meet you, Pharaoh. I see a regular in chat. And Green Yoshi. Yep. For those that don't know, I am the third Ryan from MLH, and I am also a staunch blue team supporter. Hello, Grumba Chairfix. If you think lettuce is cool, put some lettuce emojis in chat. I really do enjoy some lettuce emojis, and if you want to cause a little bit of chaos, put it in the MLH general as well. So yeah, if you want to follow me, my socials on LinkedIn and Insta are at LRyanLE. Oh, I can lower it. Yeah, I'm so sorry about that. Yeah, I put it as some background music so we're not listening to just my voice. So, all right. Okay, so thanks for the lettuces, guys. All right, so what are we going to be doing today? We're going to be building our first API. So to kind of give some reference here, we're going to be building off of absolutely no background. So if you don't have any background at all with APIs or Postman or JSON or any type of API development, don't worry, you're in the right space because we're going to be covering this with the assumption that everyone here is a beginner. All right. No problem, Shimmery. Okay, so to kind of give an overview of the session roadmap, we're going to be having 3 sessions, part 1, 2, and 3. The first 2 are going to be covering building your first API, and the last one's going to be focusing more on securing and authenticating it. So if any of you guys or any of y'all are familiar with OAuth or the Open API, or sorry, Open API, the what's it called? There's like a standard for it that Swagger made. Essentially, we'll be covering all of that in part 3. We're going to be holding 1 session every single day. For the most part, today is going to be at 7 p.m. Eastern. Tomorrow is going to be at 5 p.m. Eastern. And then the last one's going to be at 1 p.m. Eastern. So yeah, let's get into it. Hello, Arkansas. Oh, I love the name. I didn't even realize that. All right, so to kind of give a roadmap of what we'll be covering today, we're going to be covering every stream. We're going to be covering the concepts in 2 segments. And there's going to be a 15-20 minute break in between each of them. So for segment 1, the main topics are going to be introduction to APIs, RESTful API concepts, as well as setting up your environment. So basically covering the fundamentals of APIs, what the different types are, and then kind of giving us the scope of our project that we'll be creating together. Then after that, we're going to get more into RESTful, which is what we're going to actually be implementing. And then we're going to start creating our environment for segment 1. In segment 2, we're going to define what CRUD operations are, and we're also going to see how we can use that in our project. Then we're going to learn how to set up SQLite as our database and basically integrate that into our API. And then after that, we're going to actually start using Postman and start taking and posting information to these endpoints, which leads us into, I guess we're going to cover more about what it is in tomorrow's stream, but tomorrow's stream, we're going to be building a front end to actually get information from our API. So if you guys have, if you all have any questions before we begin, feel free to put them in chat, but I guess we're going to get started now. All right. So you might be thinking, what is an API? For those not familiar, APIs drive almost everything that you do. Literally, if you go into a website, you're interacting with so many APIs. In fact, you can check it if you right click, go to inspect element, you open up that networks tab. Let's see if we can do that real quick. And you go to network. So if I were to reload this page per se. Oh, ignore the spoiler. Yep, if you reload the page, you can already notice that there are a lot of network requests being sent. For the most part, these are all either resource requests or they're hitting an API and getting that information back. So if we were to go into one of these requests, like this one, you can see that you have a request URL, a method, and just other hoo-has that we'll get into later. But essentially, the idea is that these APIs power everything that we do. You're using it even if you don't think you're using it. You're using it when you're not aware, essentially. So APIs are application programming interfaces. These basically mean that, actually it's kind of self-describing in a way, because it is an interface for your application that you program and that programmers can use as well. So it's kind of, in the sense of an interface, it has an input and an output, or it has a side that's requesting and a side that's giving. So I don't know if that makes any sense, but we'll get into an example in a bit. So yeah, so with APIs, you can use it with programming functions. You can also use it as a tool, and you can also use it with different protocols. So it's very flexible. It's kind of an overarching umbrella for the different types of ways you can get and post information. Besides that, APIs also allow external applications to access and interact with the features such data of a platform. So with Google, with Google Slides, you can see how all of these different endpoints are taking information from us, but also giving us information back, and that's how we're able to see the information here. If you want to think of it from a more programmatical approach, you can also think of it as these slides are stored in a database, and that information is retrieved using an API GET request, which we'll also discuss later. But essentially, you have a source of data, you have this interface, and then you have the client, which is this website. And with that, you're able to grab information and retrieve it back. So that's kind of the entire gist of what an API is. So saying that, let's use an easier concept to describe this. Let's use the chef, waiter, and customer example. So imagine yourself at a restaurant, and imagine yourself wanting to get some food. What is the first thing, or what do you actually interact with to get food? Of course, you have your menu, but you also order with the waiter. This waiter will then, or I guess we can do this. So imagine you have your order. The waiter gives your order to the chef. Then the chef can in turn read it, process it, retrieve what he needs, put it together and format it, then give it to the waiter, and the waiter can give it to you. So if you want to think of it, you're essentially, you have this defined schema in a way, or this defined outline of instructions. You use this, and the waiter will give it to the chef. And then after that, it brings it all back. And I guess I'm gonna I forgot real quick. I need to send out the check-in. So if you guys want the free swag, I would highly recommend checking in. So if you guys haven't already, there is a link posted in the Discord. So I'll just post it in here. Please check in. It builds your swag. So if you guys want that, feel free to do it. After that, there are different types of APIs. So I'm going to actually close this right here. Yeah, so there are 4 major types of APIs that you will probably commonly run into. The 4 being RPC, SOAP, REST, and GraphQL. The ones that you'll probably see more in action nowadays is probably going to be REST, RPC, and GraphQL. SOAP has essentially been nullified, and it isn't very used. Isn't used often anymore, and it has been taken over essentially by REST. But in terms of everything, it all boils down to the pros and cons and what you want to leverage from each of these types of APIs. So, kind of getting into everything, you might ask yourself, I've heard of REST so much. What does REST mean? REST is essentially just a very flexible way of interfacing with data, and it stands for representational state transfer. So kind of an arbitrary name and kind of ambiguous, but essentially means that you have a schema, you request information in that schema, and it gives it back to you in a specified format that they have. So mainly 6 architectural constraints, which we'll get into later, that define how REST works. But besides that, the difference between that and SOAP, RPC, and GraphQL is that SOAP has an enveloped message structure. RPC is more local procedure calling. So I guess I'll get into that in a bit. It's kind of confusing the way it works. And then GraphQL is a schema and type system, or essentially the schema that you ask for is the schema you'll get the data back in, which makes it really, really kind of morphable. So next is the format. REST can be in XML, JSON, HTML, and plain text versus SOAP, which is XML strictly. And then RPC is also in JSON, XML, which are the two most common, but also a few others. And then GraphQL is JSON strictly. Outside of that, REST is a very, very easy type of API to learn, which is why we're going to be covering it today. SOAP is very hard because it's so strict, which also, in a way, makes it better as it's more robust, and it's better for enterprise solutions, some may say. And then RPC is also pretty easy to learn. And then GraphQL, you have to be familiar more with JavaScript because it's JSON only, but because of that, it is a medium type of learning curve. After that, the community behind REST is extremely large. The community behind SOAP is really small as it's been pretty much overshadowed by everything else. RPC is also pretty large. You all might have heard of Google RPC, which is gRPC. That's really massive. It's a really good way to call stuff. And it's a really, essentially, I don't know if I'll get to cover this, but you can subscribe to streams, and that in and of itself is really, really useful versus REST, where you create a connection. Once it responds back, it closes itself. And then after that, GraphQL has a growing community. It's not the most popular. It used to be more popular, but it is no longer, unfortunately. Besides that, the use cases for each of these types of APIs, REST APIs, are can be public, and they're in pretty much anything. SOAP is more useful in payment gateways, identity solutions, telecommunication, stuff that essentially can't have any fault. They have to have a very robust system so that stuff doesn't fail. After that, RPC, you can use it for command and action-oriented APIs, internal high-performance communication, and massive microservice systems. So think Google. Google has so many tiny products in each of their applications. They have micro products in their products, which are actually micro products of bigger products. So if you think about this, there's so many different types of communications, and RPC basically solves a lot of that, as it is very, very efficient in these high performance, high load systems. And then GraphQL, useful more for mobile, because in mobile, you really want to just get what you request. And then at the same time, can be used in complex system and microservices, as it has a little bit of overhead, but pretty much what you ask for is what you get. All right, that was a lot of explaining, so let's use some examples now. So as shown in that chef example, what REST APIs essentially have are two different sides of everything. You have a client and a server. Whatever client you have, whether it's a desktop device or it's a mobile device, sends a request to this proxy server, middleware, API, call it what you want. For now, I'll call it API. It sends that information through, requests the information from this resource, and that proxy server or API will request it from the server, and then go the other way around, and that server will give it back to the proxy, and proxy back to the client. So it's a really intuitive way to think about everything, and very, very simple. After that comes RPC. RPC is probably a bit harder to understand, but in the end, it's not too much. But essentially the way it works is that a client invokes a remote procedure, which essentially basically just, it's like, imagine you have a lot of different services and it knows which one to do. So if you have a client, you have your client functions, client stub, and your runtime. If you need anything from your client, it just uses one of these functions. These functions will group it up into a stub, and these stubs will basically be served to the runtime, and that runtime will communicate the other way around. And it's decoupled the exact same way. So you can use this for unary data transfers. So if you just want to get information from them, you just request and they give back. You can do server streaming, where you give a request, and whenever the server is ready, or whenever it wants to send something back, it holds that connection and sends it whenever it needs. It can be the other way around, where the client is listening to the server, so the server will send whatever it needs, but the client will always be there to listen. And then bidirectional, where it's kind of completely asynchronous. So think of if you're playing bingo online, it's bidirectional streaming, where the server doesn't know when you're going to give data. Sorry, let's say you have a bingo online and you're playing bingo with another player, or let's say you're playing Fortnite. When you're playing Fortnite, you have a lot of information about players around you. And with this, you're going to be waiting for them to give the connection, and they're going to be waiting for you to get the connection. And in a way, that's also how hacks happen, because they just listen to all of these open ports. So kind of hard to understand, but it's, in a way, the pros of it is just it's very straightforward and simple. If you think about it, you have something that listens, something that sends, and it can also just, it could work like that on both sides of the equation. It's also really easy to add functions. So if you want to continue to add stuff, it groups it all by stub. And then because it groups it by stub, it's also very performant, as it is just very efficient in how it deals with data. The only problem with it is that it is it's kind of tough to work with the underlying system. RPC isn't very known except for the probably niche developers. And sometimes because it's so easy to create new functions, you have function overload where you have a crazy amount of functions. And if you are a new developer looking at this code base, it's hard to understand. All right. Next is SOAP. This is probably one of those API types that I don't have too much familiarity with, unfortunately. But essentially, it all boils down to think of REST and think of it completely formatted in XML, which is very similar to HTML. It's a highly standardized and strict protocol where everything is set up in a specific way and it must be followed. So think of it as an envelope where the envelope has a tag at the beginning and the very end, which is in a way XML, if you think about it. And the body has a section where you can, the body contains the response or the request. It's in the same format. And the header is the information that just basically outlines like the to or the from in a letter. And then it can also submit back errors in a way. So it's very, very similar to, if you want to think about it, just sending a request and what a request looks like. In fact, it is pretty identical. So yeah, the biggest pros for this is that it has built-in error handling. It's language and platform agnostic because it uses XML. It doesn't matter what you're using. There's no JS in the JSON. There's none of that. And it has a lot of security extensions, which you can see in this example, where it is basically built to where it's really easy to encrypt and secure your messages. Only cons is that it is XML only. It's very heavy because there's a lot of overhead, and then to kind of extend off of this, you need very specified knowledge. All right, after that, we have finally GraphQL. This is probably one of those more avant-garde type of APIs because it is very new in the sense of how we send requests. So it works in 3 different prongs, where you basically want to define how you present your data. Then you want to define what you want from that, what you want to get, and then you get the result. So let's say that we create this type in TypeScript, and we're going to call it project. And the type contains 3 different key value pairs. You have a name, which is a string. You have a tagline, which is also a string. And then you have contributors, which is a user object, an array of user objects. So an array of users, essentially. With that, what you can do is you can just project and give it a name. For this, they're using GraphQL, and just ask for a tagline. And with this, whenever you project it, it gives you the result of the projection, and it's just going to give you the tagline itself. So when you're projecting and pulling information from GraphQL in this GraphQL database, it is returning you what you asked for, which was tagline. So if you wanted to change this right here from tagline to like, let's give an example of business name, it would only return to you business name. So what you ask for is what you get, and it doesn't have a lot of other junk that you might not need. So this diagram kind of shows how it works. I'm not going to explain it too much, but essentially you can also work with this in multiple types of databases, and it aggregates everything to only give you what you need. All right. I am going to take a quick water sip before we continue. All right. Okay. So that was a lot of information. I completely understand. It kind of zoomed to the entire definition of an API. But if you need to know one thing, especially for programming in hackathon type projects, try to memorize this chef, waiter, customer example, where you, the customer, looks at your menu. When you see this menu, you know what you want to get. This menu is telling you that, okay, a waiter's going to come by in a bit, and they're going to take this information. So you know who to ask, and you know what information to give. With this, you can give it to the waiter. The waiter will give it to the chef. and the chef will read it, process it, format it, and present it in a way that you need. And with that, so let's say if you're ordering a burger, he's gonna put the 2 buns, the meat, the lettuce, the tomatoes, etc. on it. After that, he gives it back to the waiter, and the waiter gives it to you. The waiter, in a sense, is only a middleman, which is why you might hear the term middleware, and it's just an intermediary to basically deal with you and deal with the resource, or deal with you and deal with the database. So that is probably the most important concept here. All right, so to define our project, I guess first I'm going to take some open responses. If any of y'all have any ideas of what type of project you're looking to, what type of project you're hacking right now, stuff like that, and then I'll show you what type of projects that we'll be creating together. So if any of y'all have any ideas for what type of application are you building, what source of data do you want to use, what language are you going to want to code this in, and then what framework or library do you want to extend off of to actually code this API. If you have any background knowledge, see if you can try to come up with something real quick, and I'll give you all 2 minutes real quick. And if you have any ideas, feel free to put them in chat. All right. I'm new to using APIs, so I'm excited to try out the Pokemon API. Oh, that's a good one. I might actually pivot to that. That's kind of fun. Okay, I can't think of anything other than something agriculture-based for the purpose/data. Honestly, that's a good one. As far as purpose goes, it could be trying to inform farmers about different different crop types, and the data source would be basically a data set of just different types of crops and different use cases. Cat memes using JS, I love it. That's actually a really good. Oh, I kind of want to do all of these. If we have extra time, we're going to do all of them. We'll do as many as we can. Going to work with the Spotify API this time around. It's going to be a web app. Ooh, okay. So if you want to tune into tomorrow's stream, we're going to be showing you how to actually interface on the other side with getting and retrieving information from these APIs. And then I would say whichever language is recommended by yourself. Yeah, so for me, I am a Node developer. So for the most part, I deal with Next.js, front end, not front end, but like Node-based projects is what I'm most familiar with. But I'd also recommend looking into Django or looking into, actually, I recommend Go if you're looking for something new to learn. But if not Go, I'd recommend Django, Flask, anything of that sort. A Firefox/Chrome extension, that's awesome. Yeah, that's definitely a really nice thing to use when you have an API. And then I would like to build an app that gives a list of anime based on genres or previously watched ones. I was thinking of using Anime List website API, but I'm not sure where to get started. I'll see if I can find a resource about that actually. That's actually a pretty cool project. Definitely going more into the data science type projects, which is what I love to see. If feel like Spotify app would work perfect with the Django framework. It would work pretty well with the Django framework. Was thinking of doing something with the Spotify API too, but with Python. Yeah, I love Go. It has a lot of extensibility, a lot of just really cool things. I love the type safety of it, the built type safety, compared to just using TypeScript. I'm not a fan of TypeScript, but I can get into the entire debacle later. It's Go is a great language to learn, and it's very marketable right now. So the MyAnimeList does have an API, which is really interesting. That's a cool project. Go versus Node for the backend. That's a really good question. In situations like this, it really depends on your familiarity or the company's current code base. So let's say you're working in the finance industry, you're probably going to be working more with Spring Boot, which is Java. And essentially the idea there is that even if there is a better framework, you work more for coherency with the main, like whatever company you're working standard is. So if they have multiple, you'd pivot to that. But if you're looking more for personal projects, I think it's purely preference. For me, I would do Go for backend. I would do Go for the middleware. But Node, I'm gonna do it because it's really easy to do. And then I only hear good things about TypeScript. Haven't delved into it though. Oh my. Yeah, TypeScript is awesome because it provides type safety to your code, which essentially means that if there are any errors, you're going to catch those errors at build or compile time versus catching them at runtime. So essentially by saying that, let's say you have think of like a cell wall in biology, right? Think of TypeScript as saying that only this type of I don't know what to call it. I'm not into biology too much, but only this thing can get into that cell, right? It's defining what it is versus JavaScript would just take in and say that there is a hole in this cell and you can go through, right? Like anything can go through if it can fit through that. So that's kind of the idea, is that it just strictly requires a certain format for every in and out that you have. So it's really solid. The only interesting thing with that is there's been a lot of debate in the CS and open source community right now about TypeScript versus JS docs versus I'm good enough and I won't make mistakes. So there are a few interesting conversations if any of y'all listen to Theo or the Primogen. Oh, welcome Greyvox. Glad to have you here. I've heard Spring Boot is more preferred in the... Oh, actually, we're a little bit through our presentation right now of kind of beginning with APIs. For the most part, we covered REST and a few other APIs and their use cases, pros and cons, etc. We'll be working on a project in a bit together, probably after the first segment, which also brings me to each stream has 2 segments, one at the beginning, one at the end of the 2-hour block, and then we're going to be hosting a stream every day, today at 7 p.m. Eastern, tomorrow at 5 p.m. Eastern, and then Wednesday at 1 p.m. Eastern. And then, so I'm a bit backlogged on these chat messages. I've heard Spring Boot is more preferred in the security field and never could find a good reason why. That's a good question. I've never really delved too much into Spring Boot. I have a little bit of experience with it, but for the most part, it just feels like you're extending Java way more than it probably should. With they're not called annotations. I forgot what they're called, but it feels a little bit unparadigm. Like I don't know the right word for it. But it doesn't feel like that's what Java was meant to be. It feels very weird. Oh, the security focused people in Sweet. Yeah, maybe it's because it's easier to secure packages in Java. That might be why. Yeah, Go is so fast. Yeah, Speed goes the way. Oh, yeah. Thank you so much for catching that. Sorry about that. Should have caught that a while ago. Okay. Actually, I'm not entirely sure how to get rid of it. It's kind of funny. I'll make something funny then. Give me 1 second. There you go. All right, and I'm gonna lower the music. All right, thanks for the catch. I appreciate it, Greyvox. JSDoc is pretty annoying to write now. It is really annoying. I don't know what I prefer TypeScript over JSDoc. It just feels even weirder. I don't know. it's so weird. Now what we need to do is build an API in C++. Oh my god. Honestly, I implore you to do so. If you could build an API in C++, be my guest. I just prefer. I don't know. I love C++. I have a love-hate relationship with it, but I feel like for web applications or for APIs like this, I prefer to be a little bit closer to the source and the type of information we're retrieving. At Wildebeest, I haven't really thought that myself, but I will say if you know Java, it's a lot easier to start with that. Though it's also considered to be a very bloated and heavy framework. It is. It feels like a weird language to use as a API language versus using something that's closer to the web page. It feels very weird. I feel like Java wasn't intended to be used for web, but at the same time, Java wasn't intended to be used for anything. It was just a use all ling. Rails and JS. Oh, I love R on R. I wish I got to learn more R on R in my time. If you like chat, y'all should sorry. Y'all if y'all I can't speak. Oh my gosh. If y'all like lettuce, y'all should put some lettuces. I really enjoy some lettuce. I'm reading the Discord now and I really appreciate the lettuce. The goal is to replace Blage with lettuce eating. And also for people who don't know, the context behind the lettuce gag is it's kind of top secret, so don't spread it anywhere else. But the idea is that I'm the third Ryan, but there's a Ryan before me, Ryan number 2, who was, I think, the vice president or president of his school's lettuce club. And essentially the fastest person to finish ahead of Iceberg Lettuce becomes the president, and then the VP is second place. And the other Ryan finished it in 6 minutes 12 seconds, which is crazy. So our goal is to basically implant the idea of lettuce in MLH with the tagline of healthy hackers and get more people to eat lettuce. It's an awesome initiative that we're trying to push right now. So if you want, add some lettuce to your name. It's awesome. You know, I'd be down. One of our main streamers, Dimmer, he actually has a challenge on Twitch that you can redeem, I think, for 10,000 points, where he'll eat a head of iceberg lettuce on stream, which is pretty funny. But you know, if we can get the community more interested in lettuce, we could have one of those one day. So, yeah. All right. Okay. So getting back into the presentation, let's get a gulp of water real quick though. Getting back into it, we're actually going to do something pretty interesting. The idea is that this is going to be mostly a read-only project, but we'll delve into that in a bit. So as far as our project goes, the idea is that we're going to work with world wonders. So think of places like Alhambra, Stonehenge, the Eiffel Tower, Statue of Liberty. Basically these world national wonders that are all around the world. There's so many of them that it's really hard to kind of find them on the maps. It's also really hard to be educated in them, and our idea is to solve this, building a full stack site for it. So yeah, so we're gonna source all this data from this Kaggle dataset that I don't want to butcher the name, but it's the dataset that they provided. We're gonna be using Node/JavaScript, and specifically we're gonna be working with Express because it's really easy to get started with, really easy to use, and I love how simple NPM is. So yeah. Any questions before we get into it? Psych. We're going to continue with more RESTful API concepts. All right. Okay. So okay. So if you guys remember from earlier, I can actually go back a bit. If we go back to the beginning, there is something that we defined. Yep. REST has 6 architectural constraints. These are the 6 most important parts to keep in mind with REST. And if you can understand all 6 of these constraints, you'll understand how REST APIs work. And it pretty much defines the entire architecture of it, really simply. So, yeah. The first one is a uniform interface. The idea is that the resource should look the same no matter where you ask it from. So if you request the resource from your phone, if you request it from your MacBook, if you request it from any device, a Pi, etc., the resource should look the exact same. The URI or the URL that you use to get the resource should look the same. The information that comes from it should look the same. Everything's the same. It's uniform. The same piece of data should also only belong to one URI. So the idea is that, let's say you have mlh.io/hello world ? Name equals Ryan, right? So you're saying that your name is Ryan and you're trying to get a hello world message or a hello Ryan from this. Also, I'm not sure that that link works, but the idea is that no matter where you submit that from, it's always going to give you the exact same thing, no matter what. The resource is uniform no matter where you use the exact same link or the exact same request. It's the exact same everywhere. It's uniform, or it's a uniform interface. And the resource should only contain needed information. So the idea is that you request this, you're requesting hello world. You shouldn't be getting a bunch of other data back that you don't need. It should only contain relevant information. After that is client-server decoupling. The idea with this is that the client and the server are completely independent of each other. They have absolutely no connections. They should be able to run independently of each other, etc. After that, the client only needs to know the URI or the URL of the resource. So essentially, let's say with the mlh.io/hello world example, you only need to know that URI, and MLH is going to take care of everything else after that. Yeah, I can put the slides afterwards. Yeah, so essentially you have this source of information and it's gonna grab everything. The API is kind of this middleware or this middle person, and it knows how to get all the information. So all you need to know is the person itself or the waiter, and the waiter knows which chef to go to. And besides that, server application should modify the client application. So basically the server can't do anything to the client. It's just that the client will send information, will request something from the server, and the server will respond with the request. That's basically it. The server can't control the client can't control the server. So, yep. Next is statelessness. This is really, really important. REST APIs are stateless. That means that it does not save your information. When you request something to, and you get information back, it doesn't contain state. It doesn't memorize that specific request. It has no idea what you requested before. So think of it like, let's say you want to have a request and it gives you information about what was previously requested. Essentially, if you do another request trying to ask for the previous request, it won't work because it doesn't contain state. It is stateless. So basically each request needs to contain all information necessary for processing it. So everything you need should be in that one request. You shouldn't have to send multiple. And then REST APIs do not require any server-side sessions. So essentially, you do not need to connect with, you don't need to contain a session. You don't need to have a session with a API. It's gonna have the request. You're gonna send the request, and it will respond back. So it's kind of the difference between RPC, where it is stateful, and it does require server-side connections, or can require it. And then after that, server applications aren't allowed to store any data related to the client request. So essentially, you're not supposed to be storing what any client asks of you. You should only be taking it, reading it, responding to it. Basically it. After that is cacheability. This is probably one of the most effective strategies and why the web works so well. This is also why you don't see people send like racking up a lot of data charges if you guys post on Vercel or anything like that. It's essentially a really good strategy to reduce the amount of requests you send. And saying that, essentially resources should be cacheable on the client or server side. So think, let's say you're trying to get an image from this API, and it doesn't change at all, right? So the idea is that there's going to be a caching strategy where when you request this resource and you get it back, your browser is going to know that it is from this URI. It is going to give this resource, and it has like this signature on it, right? And if the signature doesn't change, you don't need to get that resource again, and they can just use what your browser has cached. Same thing could be said on the server side, where on the server, if it gets a request for this resource and it has to get it from a database, it can just cache that if it needs this resource, it has this response, and it doesn't ever need to interact with that database again. So it basically, whenever you need to repeat the same information, it makes it to where you don't need to make a brand new request. It will just pull it from cache. And then server responses need to contain information about whether caching is allowed for the resource. So for a client to know if it can cache it or not, the server has to let it know. So that's kind of what that's saying. And then goal is to improve performance on the client side while increasing scalability on the server side. So if you think about it, in your if you're on Google Slides and you're scrolling through slides back and forth again, your browser is caching all of those different slides and all information related to it, unless there is a change. And that's where the second bullet point is defining a strategy to where it knows when and when not to cache and when it needs to revalidate it. And with this, it makes it to where you don't spam Google servers with, like, every time you pick a new Google slide, it's downloading these images, downloading all of that. It essentially makes it a lot more efficient. With that is our fifth strategy, which is the layered system architecture. I'm gonna take a break or a quick breath. All right, so with the layered system architecture, calls and responses go through different layers. So think of it as with the customer, waiter, and chef concept, there are multiple layers. Now let's assume that from the waiter, there are multiple chefs, and each of these chefs have their own sous chefs. The idea is that whenever you send a request, let's say you're trying to ask for them to make a burger, the burger order is going to go to the waiter is going to give it to the chef, and the chef is going to distribute all those individual tasks to all of his or her sous chefs. With that, you can't assume that the client and server applications are directly connected. Whenever you request something from the server, it hits that API, and that API, you can't assume that it's going to go to a specific resource because it could have these caching strategies, revalidation strategies, stuff like that. So assumptions can't be made. In reality, the only single source of information should be that URI that you request from, which is your API or middleware. Besides that, there may be an infinite amount of intermediaries, but neither the client or server should be able to tell. So let's say that like this API is actually, let's say that your client is actually sending information to an API or a request to an API, and that API is sending another request to another API, and et cetera, where you have this massive chain of API requests to other APIs, and eventually it goes to this resource that it reads, and it pushes it all the way back until you get that resource that you requested. This is basically saying that at any point in this line or this chain, it should never ever rely on anything past the requester and the receiver, and vice versa whenever it's sending the information back. It should be completely independent. And then after that, you should be able to code on demand. REST APIs usually send static resources, which is basically, think of it as a text file, JSON, HTML, XML, etc. But responses could also contain executable code. This is a really rare case that you probably won't run into, but an example would be Java applets. And in these cases, they should only run on demand. So pretty much those are the 6 concepts: uniform interface, client-server decoupling, statelessness, cacheability, layer system architecture, code on demand. If you fulfill all 6 of these requirements, it is a REST API. All right, I'm taking another water sip. All right, the next thing is HTTP methods and status codes. If you all have taken any networking class or any class that focuses on front end, you might be familiar with some of these concepts. The idea is that, I guess it's kind of hard to explain, but think of it as this is one of those developer or how do I explain it? This is one of those more ambiguous requirements. What do you think? That was a good question. Thank you, Arkansas. I'm not entirely sure. This is, as it mentions, it's optional. But the idea here is that if you need, you can get code on demand. So REST APIs normally send back like responses or payloads that are static resources, but it can also contain code. So the idea is that it can optionally also give you code on demand. Hope that explains it. Okay, getting back into everything. Y'all might be familiar with some of these status codes. You might have seen it whenever you accidentally go into a page and it says that your access is denied. Or you might have seen it when you go to a resource that doesn't exist. So you get a 404. But these are the 10 most common HTTP code status. Start again. These are the most common status codes that you can get whenever you interact with a resource. Most popular will probably be 200, which is a successful request. Then maybe a 404, which is it's not found. Then a 500, let's say your server is down. That's a server error. Maybe you aren't logged into a site, so you get an authentication error, which is a 401. Let's say that there's some error on your side and the code can't process what it needs to send to the server. So you might get a 400 bad request. 304 is for a caching strategy. And then 204 is, let's say it can't return anything, like a delete request, stuff like that. So those are the 10 most popular status codes. I'll leave it here for y'all to read, but you can also go to the Mozilla Developer Network docs, which shows you all of the status codes. Pretty much. I also realized I forgot to include MDN, what's it called? HTTP methods. I forgot to include this, so I'll also cover this ad hoc. So, yep. I'll kind of explain this first though. So the idea is that HTTP status codes are the responses that defines how the data request went. So if you get 200 from a request, that means it was successful. If you get 500, that means the server was down. If you got a 404, that means that the request that you're getting doesn't exist. Sorry, the resource you're trying to get doesn't exist. So these are essentially the responses and kind of labels, or think of it as like a price tag on an item if you're going to Walmart per se, and it just defines what it is or what the response was. Saying that, there's also, this is kind of completely different, but you have HTTP methods, and these are the types of methods or requests you can send when dealing with web requests. So yeah, I'm going to zoom into this. So the 4 most common ones that you will probably ever see or use are get, post, delete, and patch. Those are the 4 most common, and these we'll cover later with CRUD. But the idea is that whenever you're working with a database and you're using an API as kind of a middleman to deal with everything, you're going to want to be able to create information. You're going to want to be able to, what is it called? What is R in CRUD? I kind of forgot. Does anybody want to take a gamble? Take a gander. What is the R in CRUD? Read. Thank you. I completely forgot about read. You might want to create a resource. You might want to read a resource. You might want to update a resource, and you might want to delete a resource. Thank you so much. I forgot the R in CRUD. I forgot about reading. All right. So create you can use with put or post. Read you can use with get. Update you can get with patch, and delete you can get with delete. And they kind of do as mentioned. Put is a weird name to create a resource. It's not the most semantically named thing, but if you want to think about it, you're putting information in there. That's create. Patch, think of it, I don't know why they didn't name it update, but that refers to code that doesn't run constantly. It only runs when it's told to or called. I think that's one interpretation of it. Yeah, okay. So patch is basically updating a resource. Not the most semantically named name, but we deal with it. And then the 2 most common methods that you will probably ever see or use will be get and post. These are so incredibly important. You will use it anywhere. In fact, if I just inspect element, open this back up and go to network, and I reload this, I can filter it by requests, and yeah, you can see that most of these are get right here. Can I zoom in actually? I can't zoom in. I'm so sorry. Yeah, if you guys squint your eyes, you can see that it's a 200. Okay, and it's a get. You can see that who am I is get and 200. This favicon is a get. Get is a get. This one's a post. This is a post. This is a post, and then 2 more fake gets. So just getting on Mozilla Developer Docs, you can already see that most of the requests are gets and posts. If you go to any resource anywhere, for the most part, you'll only be seeing gets and posts. Creates and updates, patches, all those stuff. Those are pretty rare, and they're only used when you're trying to update or actually modify information. Press Windows plus. I'm on a MacBook. Oh, you're so right. Command plus does work. You're awesome. Thank you, Sweet Tank. I appreciate it. The more you learn. Yeah, awesome. You can see the posts gets. Yeah. So explaining all of this, get is the read information in CRUD, and post is a, how would you define it? I think it's a more variable version of read, but it could also be used for create, update, and delete if you want to extend it enough. Technically, any of these could be used for CRUD, but semantically, get and post are used for reading information. The only difference is that get can only use headers, and it can't use a body, versus post, which can use a body. So if you want to think about it, in a get request, the one thing that an easy way to memorize it is that a get request can always be used in your search bar in any browser. You can literally use you can make an entire get request in the browser. So if you want, if you are familiar with seeing the question marks, maybe the ampersand symbols in your URLs, those are essentially parameters or query parameters, and those are used, I guess, not per se in headers, but I guess they are kind of like headers, but essentially that's the only type of information that you can request and form your requests with, and that's how it will basically that's how you define the schema that you're looking for. Sorry, so you define the schema that is used to get information. I am mismatching all of my terminologies. Anywho, post is used if you want more data, or if you want to, not more data, but it's often used to actually have a side effect or change in a server or source, and it has a body which allows you to have a lot more information. So let's say you want to authorize something, you don't like put a security token or key. If you do it all in this URL, that's not very safe. Anybody who's snooping in, even though it's HTTPS, it's right there raw. It's kind of weird to put it there. Compared to if you use post, you can actually define your headers. So sorry, I was lying earlier. Get doesn't use headers. It's just strictly query parameters. But with post, you have a lot more extensibility, which we'll cover in a bit when we get to our Postman section. So that essentially covers the HTTP methods and status codes section. Next is JSON fundamentals. So for y'all, or for those unfamiliar with JSON, JSON is JavaScript object notation. It's essentially a pretty well-adopted format to define how you store information, especially when dealing with API requests where you're sending and receiving information. It's used a lot if you're doing front-end web development, and if you haven't used it before, you're all right because it's not too hard to understand. If you've ever dealt with objects before, whether it's in, I guess not objects, I'm going to say if you've dealt with, what's it called in C? Structs? Structs in C, objects in Java, objects in JavaScript. Those are probably the most familiar. You can also have objects in Python, stuff like that. So the idea is that everything is an object. When you have an object, if you recall, objects have key value pairs. Saved as a VOD, I'm unsure. It's probably not going to be saved, but I will post my slides afterwards. Yeah, probably as a PDF. All right, next. Okay, so continuing, the O in JSON is object notation, which is really important. And if you recall, object notation usually has a key value pair. Think of it as a key value pair. You have a name of something and you have the value of it. So let's say in this example over here, you have a list of Avengers. Avengers is an array of different objects containing basically instances of people or superheroes and their ranking. So you have this key value pair of name and Captain America and a rank of 1. Just a random question, someone who hasn't touched much. Are objects different than dictionaries in Python? Objects, oh my gosh, I am not the most familiar with Python. I've only done it for like machine learning, but the terminology is more iffy for me on that. So it's pretty much a dictionary. I think it's literally a dictionary, but the strategy of how they actually manage the data structure on the underneath of it is a lot more optimized, or it has a strategy compared to JavaScript objects, which use prototypes. But that's getting a little bit too technical. Prototypes in JavaScript. So yeah, so the entire structure of a JSON object is you always begin with these curly brace, and you have one pair at the beginning and one pair at the end. Those define your object. In these objects, you can have key value pairs that contain anything. Your value can be an object, it can be an array, or it can be any type of data type. So for this, you can see that there is a string title, which is your key, and it has a value of the Kaku's calling. So that will be the value, and the value is a string, so it's a primitive, or not primitive. I don't even know. JavaScript data types confuse the heck out of me, and it's so weird. Try doing plus 0.1 plus 0.2 and see if you can get an even 3. It's wacky. Anywho, you can see over here that this key is a string. Oh, also, keys can only be strings. Values can be any of the data types or objects or arrays. Those are the 3 rules. So you can see that this key of detail has another object in it that contains a key value pair of publisher and or a key with a string value, and it's just containing a few more of those: publisher Leo Brown, publication year 2013, etc. You can also see that there's another object inside of it called price, which contains an array of objects which contain key value pairs of strings. Yep. So essentially, as defined up here, basically a JSON object is just an object containing a bunch of key value pairs. If you're going to take away anything from JSON, it's an object containing key value pairs. Key value is literally a string and any type of value. So that's pretty much it. If you work with those rules, you can recursively build anything. Oh, why is there 2 slides? Interesting. All right, moving on to the next section. This is building into if you're unfamiliar with how to start coding. I'm going to briefly go over some good resources to use and look into, and it should make quick starting pretty easy, essentially. So first off, this is gonna probably spark some debate, but I'd recommend getting an IDE. I'd suggest this new one on the bottom left called Zed. It is actually built by the same developers that built Atom, which was acquired and built into what you now know as VS Code whenever Microsoft acquired GitHub. But made by the same developers. It's a hot take. I love Zed. I won't be using Zed. I'll be using VS Code for this tutorial, as more people are probably familiar with the entire graphic user interface layout of that. But if you don't want to be experimental and go to the deep end and touch Zed, I highly recommend VS Code. It is now by far the most popular IDE, destroying everything that was built up beforehand. Completely destroying IntelliJ, Visual Studio, NP++, Vim, etc. Oh, just curious, any reason why the keys have to be strings and JSON objects? Any advantages to using strings? Oh yeah, Zed is only Mac OS right now, which is really sad. Okay, so to answer that question, the idea is that if you have an object given object, that's actually a good question. I never really thought about it. In my mind, I always just quickly indexed that the reason why it's a string as a key is it's an easy single source of truth to like parse through. So let's say you're trying to look up what's it called? Let's say you have an array and you want to index it and get a specific object from it. You can use a string to get that specific value. But that would be kind of cool to have JSON objects as keys. I think it just makes it to where it's a one-to-many relationship versus a many-to-many relationship, if you know what I mean. Because any many-to-many relationship can be built using a one-to-many relationship. But to make it easier, especially to process, a one-to-many relationship makes it to where you can easily build out a parse tree. Yeah, I think it's to simplify the parse tree by using one-to-many. Yeah, they need to be hashable. They could be hashable with objects. Like if you want to get into the realm of Lee code, you can have dictionaries or like vectors as your keys in your hash maps. But I think it just makes it easy to parse, and it makes it a bit more inefficient for a browser to use. Ruby lets you use special type called symbols for objects. In Ruby, they're called hashes. Oh yeah, I love Ruby's Ruby's symbol system for object property names. Yeah. Yeah, there's so much evolution in the state of this. I think it could also be due to the fact that JavaScript has been around for so long and it has to be backwards compatible. Python, I feel like they were able to get a many-to-many relationship to be efficient because they're more new and they can afford to completely go back on what they've done before and update. But yeah, so getting back to IDEs, if you all haven't already, highly recommend downloading Visual Studio Code. It's probably one of the most common IDEs that you can use and find, and everybody essentially uses it. Highly recommend it. And if you want to be experimental and have a MacBook, try Zed. Zed is awesome. Zed is so minimalistic, it makes life so much easier. So programming languages, there are so many languages you can use to build an API with. I've recently built an API in Lisp. Wouldn't recommend it for the faint of heart. You can also use it in Java, Scala, Rust, Haskell, Clojure, Ada, ASP.NET, COBOL, I don't know what that is, Erlang, Go, is that Smalltalk? C++ or CPP, PHP, Python, what is that Camel? I'm tripping, oh my god. Wait, I literally know what that is. Perl, thank you. Oh my gosh. Sorry, sorry y'all. I had a 5 a.m. flight that got delayed 13 hours. So I only came back like 2 hours ago and had a class. So it's been a pretty long day if I'm stumbling everywhere. What database do you recommend to host your API data? Or what do you use for your projects? Okay, there's so many different answers to a question like this. It purely recommends on what your architecture is the best way to answer it. Whenever this gets more to system design where you're trying to design this entire system, because it's such a wide world to get into. You have like serverless versus servers, and you have like strategies. You can, what's it called? Shard databases. There's so many different things to go with it. As far as like a project like this, I'd recommend something very simple to work with. SQLite is very simple, lightweight, makes it really, really easy to work with, and isn't complicated and doesn't have any extraneous setup like doing a cloud database provider, for example, like Mongo, Firebase, Vercel if you use Vercel for databases, which is paid, stuff like that. So it's mainly your use case is what everything depends on. So for my projects, what do I use? I use a variety of things. My one rule is off the record, I do not like touching Firebase. I don't like Firebase at all. Firebase is not fun. Real-time chat is it's kind of one of its best features and only reason why I would use it ever. But there are better services out there that provide a free tier for you to mess with anything that Firebase can do. But Mongo's an easy one to use. Supabase if you want to use Postgres. There's also, what is the new one? It's starts with a T. Does anybody know? Tremor? What? Tensor? What's it called? I normally I can just type T into my browser as well, but I want to see if anyone knows what I mean just by saying that. Not Terraform. Oh, Pocketbase is also really good. It's just the T. It's it's really popular. Not really popular. It's kind of underground right now, but there's a lot of people, like a lot of solo devs adopting it now. I forgot the name of it. Oh my god. All right, if it comes back into mind, I'll say it. Or if anyone else knows a database service that starts with a T, feel free to shout it out, and I'll give you 5 kudos or 5 doubloons. All right. Strange how OCaml and Perl both use the same animal for the logos. That's what I'm saying. Like I wanted to call it Lisp for some reason. I don't know why. I should have known it was Perl. I'm so sleepy. Oh my gosh. Pascal, OCaml, Objective-C, and C. So for this project, we're going to be using JavaScript because for me, it's the easiest, and for most, it is probably something that you'll have to use if you ever do front end. Terso, yes, you got it. It's Terso, yes. I've used Terso for a project or two, and it's really nice. It's literally just SQLite on I don't want to say drugs, SQLite on a lot of caffeine. It's awesome. Only thing is that not recently, I think a year ago they had a quick hiccup or oopsie with their databases and they lost some data. But if you ignore that fact, pretty nice, pretty fast. Nice, yeah. Terso is awesome. And oh, thank you, Greybox. But this day has been so long. I've been jumping around airports, but anywho, getting into everything. For this project, we're going to be using JavaScript. All right, getting into now introducing this entire project to Postman. Postman, for those unfamiliar, is a tool you can use to test APIs with. It is an industry standard at this point. I don't know if y'all can see my screen. Can y'all see my screen? No, y'all can't. See if I can change my screen. One moment. All right, let's see if this works. Okay, here we go. So over here, we have Postman. Postman is basically an API testing application. And what you can do with this is you can basically just test endpoints. And if you want to think about it in a way, it's literally a browser request or everything that you saw in the network tab, but without like a pictured response, but you could also get a pictured response. So it is an awesome application. If you don't have it already installed, install it now. It is so useful. Just go to postman.com. It is awesome. And it's a very useful tool to use. So to get into the basics of everything, give me 1 second. I need to drink some more water. I'm talking so much right now. All right. So to go over the UI of Postman and what you might notice once you log in, Postman has a lot of stuff to do. It has a lot of stuff you can use, and it can sometimes be very overwhelming. What are endpoints? Thank you for asking. Endpoints, in a way, are URIs or URLs. So if you want to think about it, Google.com is an endpoint. And when your browser loads Google.com, it is actually using or hitting that Google.com endpoint, and it's getting data from that, whatever the response may be. Endpoints are basically, think of it as a resource or a thing that you can use and request from, and it will give results back to you. So in the end, if you want to think of it from your client or your application perspective, let's say you're building a full stack app, the end of what you might be requesting is going to be, let's say you're requesting from an API, google.com/hello world, right? If you request from that, that's your endpoint. It's the very end of something. It's where you get something. It's I don't know why it's called endpoint. It's kind of confusing. I'm trying to make something up right now, but think of it as a URL that you can use to request information from and get information back. All right, so you can notice that there are 5 different sections on the left side of your nav bar. The first one being my workspace. With this, you can create different collections of different types of requests that you can reuse and send constantly from. So if you're testing an API, you might have a collection for your project. And in each of these, you can have different types of requests saved. Test each and every one of them. After that, one second. All right. An environment is basically, we'll get into it in a tiny bit, but you might have headers or authorization tokens that work for different types of applications. And essentially, you can set up different headers, predefined headers, authorization tokens, stuff like that in environments. We won't be using that too much today, but know that it exists. I need to talk slower. I am stumbling over my words. Holy. History is basically a history of all the requests that you have sent. And then configure workspace basically allows you to add or remove different sections in your nav bar. All right. Besides that, on the top, you might see home. This home just gives you a quick overview of Postman. Workspace is an easy way to go to your workspaces. Workspaces are like your entire session of Postman. API network, just you probably won't use these too much. After that, the top left has just some standard stuff that you might see from software or platforms as a services, software as a services, stuff like that. Getting out of that, you can notice that right now we have one thing popped up. We have a Google request and it is set to get. Right now, if we were to send this request, we will get the response of the entire Google webpage. So this is what you see whenever you open up google.com. And this is exactly what your browser is doing. When you go to google.com, that is the endpoint. It is sending a request to that endpoint and it's getting the information back. So in this sense, we're sending no parameters. We have no authorization tokens. The headers, nothing that are custom. All of these are like default ones that Postman pre-fills. You can change some of them. Some interesting ones that you might look into sometime in the future is your cookie, user agent, and accept encoding, and then connection. Keep Alive it's a networking concept if you take networks. It's kind of complicated to explain. User agent is essentially saying what OS and browser you're on and what version it's on. So if you're on your iPhone, you might be getting Apple or iOS and then Safari. And the cookie is just a cookie value that is being used right now to store this information. But these are normally hidden in Postman and they're auto-generated. And you might need to change it if you want to have or see a different view depending if you're on a desktop or a mobile app, for example. Besides that, there's also body. Just know that you can have bodies in GET requests. I think you can do it in Postman, but it's technically not legal and it's not following the specification or definitions of a GET request. You can also have a pre-request script to run before you request the script and test to make sure that values are correct. So if you want to create an entire test suite on all of your endpoints, you can use Postman as a test suite. After that is settings. These are used for how you want to define and just work with your information and your requests. I highly recommend using these or like getting into them if you're a little bit more advanced, but if not, the default should work as well. And thank you, Pharaoh, for the Postman link. I forgot to put that in chat. Real quickly before we continue, so I can take another breather, I am going to put the link to the check-in back into chat. So I'm showing it right now. If you guys haven't already, go to this link. I will repost it in chat real quick. Give me one moment. I'm losing my voice right now. Oh no. Thanks all for bearing with me right now. In my dying voice. Alright, here you go. If you haven't already, check into the events. This is how you get points to earn swag during the event, so please don't miss out on the opportunity. Register for the event. it does good for you, and it's honestly a good way for us to just make sure we're doing everything right. All right, I'm gonna take a sip of water again. All right, okay. So this is probably a lot of information for those that are new to Postman. I'm gonna now try to explain all of these different parts step by step here. So getting back into everything, the main things to look for whenever you're creating a new request in Postman is the type of method you are using. The most common, once again, being get, post, put, patch, and delete. Those are the 4 most important ones. A cool thing to note about head is actually used in all of these requests. It's like I don't know why it's separate, but it is separate. But they're built into all of these requests. Head is basically the returning part of the header, so it returns information back to you in the headers. I'll explain that in a bit. Over here is the endpoint that you can hit. I don't know if hit's the correct terminology, but I like saying hit because it feels very Texan to me. But I'm going to use this link that Postman has provided, and it's a quick hello world thing using glitch. I'll also put that in chat if any of y'all want to use it to test with me. But basically, this is our endpoint, and we're going to try to get information back from it. So in our requests, you can see that we're not specifying anything that we want, but do know that we can with this. Anything as a parameter will be added with a question mark, param name equals to some kind of value. So you can notice as I'm typing it out here, it's auto-populating in Postman. I'm also going to zoom in if I can. Yeah, there we go. So you can notice as I'm doing this, it's auto-populating in Postman. If I add the ampersand sign, I can also get another one. So let's do param2 equals hi chat. Yep. And kind of the entire thing behind this is the first parameter will always begin with will always be prefixed with a question mark, and after that it will always be prefixed with a ampersand symbol. And then param names are strings, and values are also strings, but technically it could be a string that is actually an object, and whenever you get information back, you can just parse it. It's kind of complicated, but everything URLs are conveyed as strings, so think of this entire thing as a string or serialized as a string. For authorization stuff, this is if you're working more with OAuth, which we'll get into day 3, which is Wednesday. Headers, let's say that you want to provide a what's an example? Let's say a refer. Let's say we want to make it to where we can find out who referred me. We can do some stuff here, and essentially it would just track the refer. It could be an int or a bool, but it will be stored or serialized as a string. So if you wanted to do like an int in type 1, you can notice that it will have a value of 1, but just know that it is an integer being converted into a string. So if you wanted to have an object, like a JSON object, you could also do the same thing. So I can show you here. Name is Ryan. I can do that here, but it's being converted into a string. And if I were to actually, if we were to actually submit this and check what it sends back, you're gonna notice that all of this is encoded because there can't be these special characters. So if I wanted a space in between, for example, it would have to encode that space. So this is not really what happens, but if you do this in Google, Google will automatically encode it for you, which we'll show in a bit. But yeah, it could be anything. It's just everything is serialized back as a string. So I'm gonna do param2. You technically don't need these quotes. I don't know why I did that. True is a Boolean in semantics, but would be converted to a string in this URL. Yes. All right, so whenever we send this, you can notice that with this now printified, you can notice that it's returning this HTML page, which is the entirety of this Google page. Or no, sorry, this Postman thing. Oops, new project. This project isn't running anymore. That is such a shame. It doesn't work anymore. Dang. Chinese. Oh, I'm not gonna say the last part, but you can follow along if you want, or you can also just watch me and see what I'm doing. We're gonna get more interactive towards probably the second part of the stream, but we're running a little bit over. We'll probably do something more interactive next stream. Working together. So yeah. Anywho, yeah, so you can see that it's returning this web page. You can view it raw because in the end, everything is stored as a string. And then I'm actually gonna go back to google.com. Gosh dang. Yeah. You can preview it. This is what your browser would see. It's emulating a browser essentially without CSS. And yeah, actually I don't know what that is. Is this an AI thing? Oh, it's an AI tool, LOL. Yeah, so this is the body response. So the payload or the response is always returned back in the body, but it can also be returned back in the headers. So you can see that the response is showing, is giving you information, which if you remember from how REST APIs work, it needs to define a caching strategy. So you can see here it defined the caching strategy. Also gives you a type, so whatever's reading this knows that it's text or HTML. Sorry, it is an HTML doc, so we can render it as HTML versus text/text or text/JSON. A content security policy report only. This is for CSRF. This is essentially kind of something more niche that we'll cover probably next or in tomorrow's. But it's basically dealing with cross-origin resource sharing stuff. After that is the server. This is not required. Content length is required. It's giving how big the body is. XSS protection, cross-site script protection. This is some security stuff which we'll cover in day 3. And then it has its cookie information, which you can also see in the cookies tab. So yeah, in the end, that's basically the entire dichotomy of a URL. Green Yoshi, that is actually really cool. Booleans, duh. Yeah, let's use Tarzo as an example. See if we can get anything cool here. Or what's a free API to use? If anyone has any suggestions, please put it in chat. If not, I'll try to find one as well. MealDB, PokeAPI.co. Okay, we can try both of them real quick. Let me get the MealDB API and the PokeDB API. PokeAPI. All right. So using MealDB, we can try requesting, and you can see in here we have some parameters. The parameter being s is equal to Arabiata. I don't know if I'm butchering that. I probably am. If I send this request, you can see that this time, if we look at headers, the content type will be application/JSON. So that's how Postman knows to format it as JSON, because it's telling it explicitly that it is JSON. Because once again, everything's returned back as a string, so you have to define what it is. That way the application knows how to read it. So you can see here, format as JSON gives you meals and all of these different key value pairs. And then if I were to give it, oh, can you also see? Yeah, there we go, sorry about that. If we were to, I think this is a filter one. If you do filter is equal to anything that begins with an A, we get everything that begins with A. And if you use the pokey, this is kind of getting into the entire world of how to architect an API and how to build it up. You can use parameters, you can use headers, you can use body, you can use so many different things to actually define how you want users to get your data. And that's the entire aspect of API design. And kind of getting to the world of API documentation, which will be covered day 2. Because API documentation is a massive thing, because in the end, it's hard for users to learn. So you have to define how it is or what it looks like so users know how. So instead of like the other API where I'm rambling, oh my God. The other API use parameters to query. This one is using a path name in the URI to query. So you can see if we query this ditto, we get all the attributes of this ditto. If I were to do a Charmander, we'll get all the attributes of a Charmander. And yeah, everything is basically working as part of the path name rather than a parameter. And you may ask, what is the best standard? What's the best way? In the end, that is a up to you question. A lot of people have a lot of different opinions on this, and it's fully up to you on how you design your website. Personally, for something like this, I would go with a parameter. That's me. If you work with Vercel a lot, you're probably using path. so stuff like that, essentially. Sorry, Next.js, not Vercel. Oops. Yeah. So that's the essential brief rundown of how Postman works. Does anybody have any questions? All right, if no one has any questions, we'll move on back to the PowerPoint. All right, and we actually already did that first hello world. We did get a hello world, but we did interact with other APIs, which I think is a pretty apt what's it called, replacement. But anywho, we have been doing this for a hot second, so let's take we actually don't have that much time in the stream left. Let's take a 10-minute break. I'm gonna edit that. Let's take a 10-minute break and then we can come back because I need to get some water. So yep, I hope you all stay back for the last 25 minutes of the stream. But thanks all for staying so far, and we'll finish it out with a more definitive version of CRUD. All right, BRB. All right. We are back. Yep, roughly 30 minutes left. Okay, so I took the time to look over the entire rest of the presentation, and I noticed that we probably don't have too much time to get directly into coding. So what I'm thinking right now is that I'm gonna try to push back a lot of the coding aspects to tomorrow's session. So if you're wanting to work together with me in a, I forgot what the name of it is. I'm having like brain fog right now. We could meet together collaboratively in a GitHub, what's it called? Codespace. There you go. A Codespace with building an API. Then you can feel free to join me tomorrow. But for now, I'm going to just cover the last tiny bit about CRUD that we kind of talked over earlier, but get more formal into it and specifically focus on it. And then we should be done for the day. But yeah, and then tomorrow's session will contain actually building an application with building an application with an API, and then trying to get information from it in a web page. Sounds good? Alrighty. Okay, so let me just go back to this. All right, so to more formally focus and define CRUD, CRUD is an acronym. Oh, do you have a PowerPoint that... I will post this in the Global Hack Week chat right after this stream. It should be in a PDF form, and essentially tomorrow's session will add on more to it. And with the last session, it should also finish that. So yeah, in the end, it's going to be a massive PDF that you can use. So yeah, so what is CRUD? More specifically, focusing on this, CRUD, once again, is create, read, update, and delete. Thank y'all to the people that mentioned it earlier, because I forgot what read meant, but yeah. Create, read, update, and delete. And the entire like philosophy, not philosophy, but the entire decision behind CRUD is that it's an easy to remember acronym that defines the 4 basic operations that anybody would need to do to manipulate data in a data set or in a database. So if you think about it, whenever you have data, what are the 4 things that you might ever do to it? You might create it, so you might read to it, you might write from it. Oh my gosh, you might read to it, you might write to it, read from it, write to it. Those are 2 of them. And then you might want to remove a resource, and then you might want to change something in a resource. And for the most part, you can do any form of like sub operation with those 4 main operations. In fact, a post method could actually do all 4 of those. Thank you. Yeah, I need to. This is going to be a fun week for me, so yeah, that's why I'm kind of ending it a bit early so I can get some rest. But yeah, sorry for y'all dealing with all my rambling right now and me slurring over my words. Yeah, okay. So, and then finally, it is just a fundamental concept in computer programming and especially system design to know what kind of operations you want for what parts of your code and what parts of the API, etc. It's kind of a way to design your entire data flow. So, yeah. And lastly, we're going to use this example that I found, and it's just showing the CRUD operations. It's called CRUD operations in action for this B site that provides B products. So you can see here, they prefix their API with /API, and then they use products to actually one of the products. And with specifically products, you can see that if you just request in that main endpoint /API/products with a GET request, it's going to retrieve all the recently created records. If you add on an ID to it, it's going to fetch that specific object with that ID. You can also notice that there is a GET request and a POST request for the exact same endpoint. The POST request, very similar to a GET request, it has the exact same power as a GET, but GET is specifically read. POST can actually write. So this POST request is kind of mimicking a PUT, but they have another PUT down there. But yeah, it creates a new object for the specified entity. If an identifier isn't included in the request, a randomly unique value will be automatically generated. So I'm assuming that you can also add one or add an ID, and it would also do something with that. And you can see here they're defining that with put. So you use put, it creates an entire object. If you do patch on that specific ID, it's going to update it, and then you can also delete it given that specific ID. So you can notice here that using these different types of methods and different types of endpoints and strategies, you can make it to where, let's say you sent a delete request to /API/products, it wouldn't do anything. You didn't define anything for it to do. So yeah, slowing down a bit, these are the 4 ways to manipulate data that are most commonly used. Unfortunately, we are once again moving a lot of the stuff that I had planned for later in this stream to tomorrow. So please catch me tomorrow at 5 p.m. Eastern. And yeah, it should be a lot of fun. So yeah, that's the end of part 1. We made it through a lot of the lecture and the theoretical part. So we are good to go for tomorrow when we start building on a bit of JavaScript to create an Express API. Yes, I got that right. Perfect. All right. Thank you all for joining me for this stream. If you have any other questions, I'll be hanging and lurking around in the MLH Global Hack Week chat. Feel free to ask questions. This PowerPoint is going to be converted to a PDF and added to there. If you haven't already, please don't forget to sign in. It's really appreciated, and I want to make sure that y'all get your swag. So please do that. I hope it was a good crash course as much as I enjoyed it. So yeah. Thank you guys for coming in. I am gonna go to get some sleep. that eclipse, I think, did something to me. So yeah. All right. Take care, guys. Thanks, y'all.